Welcome to my tutorial on time and work. In this tutorial, I will spend first couple of minutes on the basics of time and work, and then I have some series of questions lined up which are arranged in increasing level of difficulty. Thing with topic like these, time and work, and time spent in distance and all those topics is that there's really not so much of formulae or concepts to be learned to be able to solve these kinds of questions. You can straight away start solving these kinds of questions. It's more of approach based topics. You'll need to understand how to approach these kinds of problems. So let us start. The first thing that you'll need to understand is if A can do a piece of work in n days, A's 1 day work is 1 by n. Straightforward, right? Suppose building a wall is our one work. We call any work or one complete work as one work, and half of that work would be 1 by 2, one fourth of the work would be 1 by 4, like that. So if A can complete this wall building in 8 days, he takes 8 days to finish this work. That will mean on day one he would have worked 1 by 8. Day two he would have worked 1 by 8. Likewise, for 8 consecutive days he would have worked 1 by 8 work. That is his 1 day work or any day's work would be 1 by n, 1 by 8. Second thing is if A's 1 day work equal to 1 by n, A can finish a work in n days. That is, if we know that A does 1 by 4th of the work, 1 by 4th of the work in 1 day, right? In 1 day, by unitary method, we know that for one work to finish, he will take 4 days, right? So 1 by 4th, this is basically reciprocal. So I hope you understand these. The important thing to realize this in any time and work problem is there's really not much of concepts to say to be able to solve these kinds of questions here. I mean, these are not time and work concepts. These are concepts of unitary methods, right? Eight days, one work, so 1 day, that is per day, 1 by 8 work. So these are unitary concepts, unitary methods. So there's really no concept in time and work. Only all the time and work questions rotate around these three quantities: rate of work, that is work per day. What is his speed that he works? Rate or speed of 1 day work. Okay. Second thing is how much work. Third thing is the time we take. So all the questions revolve around these three information. In some questions, we are given a person A works 1 by 4th of the work per day, and we need him to finish one work. How much work is one? This is 1 by 4th. So how much time will it take? That is the formula, right? Not the formula. It's just that. So 1 by 4th work, how many times will he have to repeat? Keep doing 1 by 4, 1 by 4, 1 by 4. How many days he'll have to work to finish one work? That will be n equal to 4 days. So there are variants in these three. I mean, working along these three informations. Okay. So if we are given that the time that A finishes one work, we are given time, we are given amount of work, that is one work. If we are given that A finishes one work, that is here we have building a wall is one work. A takes 2 days to build this wall. So per day, how much work you would have been doing? 1 by 2, right? B takes 4 days to build. B is slower. B takes more than A. A takes 2 days. B takes 4 days. So what amount of work does B does per day? 1 by 4th work. 1 by 4 on day one. 1 by 4 on day two. Likewise. So if the question asks in how many days will they be able to finish the work if they both work together? So how many days? How we will solve this then? We know that on day one, A is giving his contribution, B is giving his contribution. Some chunk of work. What is that chunk of work in 1 days for A? 1 by 2 and 1 by 4 for B. Again on day 2, again A is working, B is working. Day 3, again he is working, B. So whenever they're working, they both are working. We know that the work per day is 1 by 2 plus 1 by 4, which is equal to 3 by 4. Do we need any more information? We know the speed which the work is being done. speed with which the wall is being created. The wall is being created, and we know, okay, and we know how much of work is to be done. One work we need to do. So when we know the speed and the amount of work, it's easy to calculate, right? So how to calculate? We know 3 by 4 is the speed every day. How many days they will have to work with the speed? N days. So they keep on repeating 3 by 4 on day 1, 3 by 4 on day 2 till day n, and we will get one work, which will be equal to n equal to 4 by 3. So this is number of days, right? Question number 3. Now the question is, we are given how much time will A take to finish one work. So these are all assumed to be one work. Whenever we say work, we know that the amount of work to be done is one work. In some complex questions, you might be given C works the remaining work or B works the remaining work. So they are not doing one work in 4 days time. They are doing that much of work, the remaining work. So we will see those kinds of questions ahead. In this case, A does one work in 2 days time, and all these three does one work in 4 days and this. That is, A is very fast. He does this one work in 2 days time. That is, every day he does half of his work. B on the other hand is slower than A. He takes 4 days to finish this one work. That is, his speed is 1 by 4th of the work per day. C is even more slower. He does 1 by 8th of the work per day and takes 8 days to finish this work. So in how many days will A plus B plus C, if they work together, finish the work? In how many days will they take to finish this one work? Again, we know how much work, one work we have to finish. So for that, we will need to know the rate of the work. So rate is given, right? On day one, A, B, and C both work. All three work. Day two, again, all three work. Likewise. So rate in which the work is being done every single day is the sum of these three's rate. So A's contribution plus B's contribution plus C's contribution every single day, which comes out to be 7 by 8. So 7 by 8 work is being done per day. Now we have to finish one work. So how many times should we repeat this 7 by 8? How many times should we repeat this 7 by 8, 7 by 8, 7 by 8? For how many days? For n days to finish one work. That is what we have to find. N equal to 8 by 7. Now, so let us start with our first questions. Now that you know the basics of time and work, the basic approach of time and work. Now we are given that for a work to be done, we know that A plus B together finishes the work in 5 days. That is, A plus B, when both of these two persons are working, they take 5 days to finish this work. That is, each day they're working 1 by 5th of the work, right? 1 by 5th, 1 by 5th on day 2, 1 by 5th on day 3, likewise for 5 days. So each day they contribute 1 by 5th of the work to finish this work. Also, we have another information that A alone takes 10 days. A is that slow. He takes 10 days to finish this work. That is 1 by 10th of the work he finishes per day, right? Now, how to solve this? We have this information, right? Now, how many does B? So our information is 1 by A, that is A's speed with B's speed equal to the speed, they combined speed. This is what we are given. And we know A's speed is 1 by 10. A's rate of doing work is 1 by 10. So we got B equal to 5. So B take 5 days to finish this work. That is to say, its rate is 1 by 5th, 1 by 5th of work per day. But this is what we required and we got this. Question number 2. A can do a piece of work in 10 days and B in 15 days. So here this building a wall is our work, right? Now A takes 10 days to do this work. 10 days. And B is even more slow. B is very slow compared to A. He takes 15 days working 1 by 15th of the work per day, and A is fast. He finishes 1 by 10th of the work per day. That is, he does more work per day, and B is slow. He works only 1 by 15th work per day. Now they work for 5 days. So The basic approach in the okay, first let us try to understand the question. So they work for 5 days. So now we know that both A and B are working. And how much they do they work? They work for 5 days. So they would have finished by the end of the 5 days some part of the wall. And the rest part of the wall was finished by C in 2 days. So we are given that C doesn't do one work now. C does rest of the work, some part of that one work, and he is able to do that part in 2 days. So for C also, we know that C does some part of that one work in 2 days. That is to say, we know the rate that how we know we would be able to find the rate in which C does that one. But for that, we'll have to find out what is that some part. How much part? Is it 1 by 4, 1 by 6, 1 by 8? That we'll have to find. Once we know the amount, once we know the work to be finished by C and he takes 2 days time, we will be able to solve. Let us see how. I'm sorry, just a minute, I'll erase this. Okay, so let us start solving. Now we know that A and B together worked. So A's speed is 1 by 10, B's speed is 1 by 15. So this is A and B's 1 day work. How many days do they worked? They worked for 5 days. How much work they would have finished? They would have finished what 15 to 32 plus 3, that is uh, 5 by 6 into 5, 5, 6. They would have finished 5 by 6 of the work. So majority of the work is finished by A, A and B. So suppose this much of wall has been created, only this is left. This will be done by C. What is this portion? We will need to know. So this is 1 minus 5 by 6. This is one work, right? And this is 5 by 6, which is 1 by 6. Now, we know that, now for C, we know out of those three quantities that we discussed initially, right? What is the work, how much work, what is the rate, and how much time. Out of these three, we have two quantities. We'll need to find a third quantity. How? C's rate would be 1 by C, we don't know. So we will say 1 by C is C's rate. How many days C worked? C kept doing with his rate for 2 days. He kept doing 2 days, 1 by C plus 1 by C. And he's able to finish not one work this time. He's able to finish how much work? 1 by 6th of the work. That is C equal to 1 by C equal to 1 by 12. That is C's rate is she finishes 1 by 12th of the work every single day. That will mean C will finish the work in 12 days. So how simple it is. You just have to take care of the amount of work in how much time. Out of these three quantities only you'll have to take care. Amount of work and amount of work, rate of doing work, how many days, right? So you will always be able to find. And in this case, we needed to find how much time will C finish one work when we knew that C finishes the remaining work in 2 days. And what was that remaining work? That we found it as 1 by 6. This was the work when C worked with his speed for 2 days. So 1 by C plus 1 by C. Question number 3. A and B can complete one work in 45 days and 40 days respectively. So if A is employed to finish this wall building, he will take 45 long days to finish this work. Working 1 by 45th of the work per day. 1 by 45th, 1 by 45th. Likewise, he will be able to finish one work. B, on the other hand, is faster. He takes only 40 days to finish this work. That is 1 by 40th of the work per day. Now, they both began working together, but then A left after some days. So we know now. So always remember to keep track when scenarios are changing, keep track of the amount of work to be done in these questions at different time points, at different points of time. So out of one work, so just remember this. Always keep track. and you will be able to solve any variation of these kinds of problems. So in this case, we know that every single day when A and B both are working, they are finishing 1 by 45 plus 1 by 40th of the work, and they work for 5 days. So how much of that one work they were able to finish? That is given by 45 360 and 45 8 plus 9 17 by 360, and they work for, oh sorry, in this case they have not worked for, they have worked for some X days. So how much work? We don't know how many days. So we will still try to keep track in terms of X. So they were able to finish 17x by 360 work, right? So this is the amount of work. So we are keeping track of the amount of work that is being finished. So when A left, they had already finished 17x by 360 of that one work, right? They had already finished this amount of work. Only this much is left. Now B finished the remaining work in 20 days, 23 days. Again, we know that B finishes this amount of work in 23 days. So how many days did A leave? So again, we know that what was the remaining work? Again, we want to keep track of this. That is 1 minus 17x by 360. This is the remaining work. And B finishes working at his rate. What is his rate? 1 by 40. Right? How many days he worked? He worked for 23. He contributed 1 by 40, 1 by 40, 1 by 40 for 23 days, and he's able to finish this amount of work. Now this makes it simple. 360 minus 17x divided by 360 equal to 23 by 40. 0 cancel. 9 times, so 23 into 9. That way we have x equal to 9. So that is what we have got. And this was our question. How many days A and B both were working, and then A left suddenly. So we had assumed X days, till X days A worked. So we have got the answer as A. So from previous questions, I hope, I would like to believe that you understood that we always need to keep track when those situation comes, when they are working, then some person left, some person joined. So in those scenarios, we will just have to keep track of the work. And since we always know the speed which they are working, so we will be able to find how many days will they take to do remaining work. If we know the speed which they are working every day, daily, that is rate we call it, and the amount of work. It's always easy to find that way, right? So that is how we will be approaching all these problems. It's really not very difficult if you think neatly, right? A certain number of men complete a work in 60 days. So if we have one work, and this one work is completed by sudden. So till now we were employing more a one person, like A, or more than one person, A, B, and C. They were together working at a faster rate. A is speed, B is speed, and C is speed. We are summing up. Now we know that it can be a certain number. There can be more than three people, four people, more than 10 people to finish this work. So it is said that we don't know that certain number of men. So we know that there are n persons. So we'll assume that n persons are there. So certain number of n, and they work for 60 days. So first we will have to assume what is the rate with which every person is doing work. So let us assume that rate is 1 by a, right? So when we assume 1 by a is one person work, and there are more than one person, in this case there were two, so we were adding, right? One day's work, A's contribution, B's contribution, C's contribution. Likewise, we will add 1 by a plus 1 by a till for nth person, also for n persons, that is n by a, or simply 1 by a times n. So this is one day's work of n persons. That is the rate we know. How much work? Now they are able to complete 60 in 60 days with this rate. If they keep working for 60 days, n by a 60 times, when they repeated this much of effort, they are able to finish one work. And we got that 60n is equal to a. This is our equation 1. We have scenario number 2. The work could be finished in 10 days less if there were 8 more men. Now again, 1 by A was the rate for 1 man per day. So n plus 8 men now working. So the rate would be 1 by 8 times n plus 8, which is equal to n plus 8 by A. Now they worked for 10 days less and able to finish the work. So they worked for 50 days. So when they repeated their effort for 50 consecutive days, they found that they are able to finish this work. So we have equation number 2. 50n plus 400 is equal to A. Now we know A, we will substitute 1 in this. So we will get 50n plus 400 is equal to 60n, and A, that will mean n equal to 40. If we solve this, this is what is required of us, right? How many men they were originally. So even in this question, it's not like somebody has left or somebody has is adding. It's so every time the work is only one, right? Only thing is, since more people are working, the rate changed. Now they are working at a faster rate. So they were able to finish the work in lesser time, right? So again, only these three quantities that we are dealing with any problems. One is how much work. In this case, one work in both the scenarios. Rate changed in this case, right? Rate increased. Number of days decreased. And we always know that if we know the rate with which they work, the rate that is 1 by 2, and we know how many days they are working for, we would be able to say how much work they would have done, right? That way. Now this question of working A and B alternately. This is a very famous question in various competitive examinations. So you would have seen this kind of questions very often, or you will see if you have not seen this. So let us try to decode this question. And this is kind of trick question. So here we are given the rate with which A work, the speed with which A finishes his work. The speed is, for A, it is 1 by 12. For B, it is 1 by 18. We also know the speed with which both of them work. That would be 1 by 12 plus 1 by 18. We take 36 as LCM. 2, 3, that is 5 by 36. So 5 by 36 of one work per day they finish. Now A began working. Sorry, this was no not needed. Let's try to see the question. A began the work. So on day one, they are never working together. So basically, we are adding it. Okay, let us try to decode this. So on day one, A worked. On day two, B worked according to the question. On day three, again A worked. On day four, again B worked. Again A, again B. So likewise, they kept on working and finished the work. So now it is not mentioned that they are working together. No, none of the days they are working together. So we don't need the rate of one day's work by adding these two. So how will you solve this particular question? To solve this question, we would need to find the rate with which the first day's work was done. That is 1 by 12. Second day, 1 by 18th of the work was finished. Third day, again 1 by 12 of the work. So basically, we will need to add all these things to get and see when does one work gets completed after adding these. But that is not feasible, is it? It is not feasible if we have lot of days to be covered. So what will we will do? We can't simply multiply 1 by 12 into, say, n number of days and equal to 1, because it is not that every single day the work is being done with the rate of 1 by 12, right? The work is being done with varying rates. First day 1 by 12, second day 1 by 18, third day different. If you observe the pattern here, and so every 2 days the work which is being done is same, right? Every 2 days work is amounts to A plus B's contribution, right? And what is A plus B's contribution when A contributes and B contributes? It is 5 by 36, not per day, it is per 2 day. So every 2 days, 5 by 36 of the work is being done. 5 by 36, 5 by 36. Now we can multiply 5 by 36 with n, right? And you would be tempted to equate it with 1. That is, you would want to find after how many days should we repeat 5 by 36 to get one work to be done. Observe carefully. If you observe even more carefully here, you will find there might be a situation when, for example, in this case, if you multiply with 7, after 7 such iterations, that is after 14th day, on 15th day, after 14th day, you would have been able to finish 35 by 36 words if you multiplied it with 7, which is very close to 1. And when you multiply it with 8, if you multiply with 8, the work which gets finished is more than, that is 40 by 36, that is more than 1, right? So I will clear this because it might get messed up if I try to explain like this. So this was the scenario. Day 1, day 2, day 3, 4, 5, 6, likewise. So every 2 days work was A plus B's. A contributed here, B, A plus B's and A plus B's. We got A plus B's if we got 5 by 36 as per 2 days work, right? So we found out that after 7 days, not 7 days, after seventh iteration, after 14 days, we got 35 by 36 of the work completed. How much work is remaining? 1 minus 35 by 36 of the work is remaining, which is equal to 1 by. This is a very small part of the work which will be completed by A's work when A worked alone. So next days would be A, next days would be B. But B didn't get to work now. A completed the work within the next day. So we stop here and we calculated with respect to A's speed, not A plus B's speed. Had you multiplied 5 by 36 with N, now you are now assuming that all the days they're working with the speed of 5 by 36, which is equal to speed of A and B combined. But no, they are working with that speed till 7th day. The next day they are working with a slower speed. The last day only A is working. So we need to take that into picture. Now it's the same question. We need to complete 1 by 36th of the work with A's speed. So the work is 1 by 36. A does 1 by 12 of the work per day. How many days will A have to work with this speed, or what part of the day? We will get this as 1 by 3. So our answer would be after 7th such iteration, that is after 7th iterations of 2 day, that is after 14 days, A alone will work for 1/3 of the 15th day. So our answer is 14 day plus 1/3 of the next day. The answer. So I hope you understood these problems, and we will be discussing more problems on time and work, on the different variations of these problems, like that of efficiency when children, men, women join the work and they are trying to do some work. So those kinds of problems we will be discussing in our next lecture. Thank you till then.